take a look at how to find the sum of a finite geometric series. So here we have our formula for the sum of a finite geometric series. S sub n, standing for the sum of the series of n terms, is equal to a sub 1, that's the first term of the geometric series, times the quantity 1 minus r to the n power, where r is the common ratio and n is the number of terms. All that divided by the quantity 1 minus r, again, where r is that common ratio. So there's our formula. Let's go ahead and take a look at an example next so we can see how to use that formula to find a sum. Taking a look at this example, we want to find the sum of this finite geometric series. To be able to use the formula that I just talked about for the sum of a finite geometric series, you need to know a few things. You need to know the first term, which I do. The first term of this series is 3. You also need to know the common ratio. I can see the common ratio here going from one term to the next. I'm just doubling, so the common ratio, the value of r, would be 2. The final thing that you would need to be able to use that formula is you need to know how many terms there are. Since I have some terms that aren't written out here, it's not obvious to look at this to see exactly how many terms there are in the series. So I could go ahead and use the explicit formula to actually solve for n, to figure out the last piece of information that I would need to use my sum formula, since I can't see all the terms. If I could see all the terms, I could just count them up. Maybe you could also fill in all the terms if you wanted to, but that's going to take a little while to get to 3072, so I'm just going to use the explicit formula to solve for that. Remember the explicit formula, a sub n is equal to a sub 1 times r to the n minus 1 power. So creating the explicit formula for this, a sub n would be equal to 3 times 2 to the n minus 1 power. And then this last term I know I can plug in for a sub n. So I have 3072 is equal to 3 times 2 to the n minus 1 power. This is an exponential equation. We've looked at how to solve exponential equations in previous sections and other videos of mine. The first thing I'm going to do is divide both sides by 3 and get to this point where I have 1024 is equal to 2 to the n minus 1. Now, whether or not you recognize that 1024 is actually a power of 2. It's actually 2 to the 10th power. I recognize that. So if I wanted to solve this exponential equation, I would do this. I would say 2 to the 10th is equal to 2 to the n minus 1. It's just, again, rewriting this as 2 to the 10th power. Check it, 2 to the 10th power should give you 1024. And now, at that point, I can just set my exponents equal to each other, and I can add 1 and get that n is 11. If you don't recognize 1024 as being a power of 2, you could certainly use logarithms to solve that as well at that point. So you can take the log of each side. So I have log of 1024 equals log of 2 to the n minus 1. Like that allows me to bring this power down front, so I have log of 1024 is equal to n minus 1 times the log of 2. I can divide both sides by log of 2. If you go to your calculator and you do log of 1024 divided by log of 2, you're going to get that that is equal to 10. And then you can add 1 on both sides, and you'll still get that n is equal to 11, regardless of how you go about solving that exponential equation. So now that I know the value of n is 11, I can use my formula for the sum. So I'm going to make note of that n is 11 for this right here. So my formula for the sum, s sub n, is equal to a sub 1, my first term, which is 3, times the quantity 1 minus r, which the r common ratio here was 2, to the n power, which we just said n was the 11th power, all divided by 1 minus r. So I have 1 minus, again, r, that common ratio there is 2. So now we go ahead and we work to simplify this. I have 3 times 1 minus 2 to the 11th power. 2 to the 11th power is 2048. So I have 1 minus 2048, which should be negative 2047 on the top there. All divided by 1 minus 2 is negative 1. So I have 3 times negative 2047, which is negative 6141. divided by -1, which is 6,141. So the sum of this finite geometric series should be 6,141. Now, again, there's a little bit of work in the middle there to figure out the number of terms. If the series didn't have these ellipses in the middle where you could just count the number of terms, that would be significantly easier. Maybe for this one, if you wanted to just go ahead and continue the pattern to write out the number of terms, figure out how many terms there were, that might have been easier as well. But if this number is very large and there are a lot of terms in between, I certainly wouldn't recommend that. I'd recommend using the explicit formula and solving for the value of n to figure out how many terms there actually are in this series.